Okay, so what we're going to do now in this video is we're going to go over a search tool with Agentcore Gateway. So what it means is that what it means is that we're going to have multiple tools. We're going to have a calculator tool, and we're going to have a restaurant tool to schedule reservations. And we're going to have different instances of this calculator tool. So the bottom line is we're going to have a wide variety of tools, let's say, a lot of tools, and we're going to use semantic search, and we're going to demo semantic search. And what that means is you can get the complete list of tools, like 300 tools, or you could do a semantic search with the Agentcore Gateway, where it gives you the most relevant tool. And the point of the whole demo is that it's significantly faster by doing a tool search to find the most appropriate tool or the appropriate two tools, as opposed to finding the list of all the tools and figuring out how to use them appropriately. Okay, so that's the bottom line. So we are in this Amazon Bedrock Agentcore samples direct. We are looking at Agentcore Gateway. We're using the search tools, and we have some API spec files here. We have a Lambda here, and we have a restaurant spec file, and we are in this notebook here. We are in this notebook here learning about Agentcore Gateway and semantic search. So let's just go through it step by step and try to understand what's going on here. So we're looking at a conversational tutorial. Agent type is a single agent. We have Agentcore services like Agentcore Gateway and Identity. We have a strands agent. We're using Anthropic Claude Haiku. We're using, we have these tutorials. We're creating a Lambda-based agent gateway from a strands agent. And we're using a Python SDK, Bodo 3, and Amazon Bedrock Agentcore Python SDK. Okay, so let's talk about the semantic search. The bottom line is the gateway manages, there's a security guard. So we're doing OAuth to Agentcore, and then we have we have some security guards in place to ensure only valid users and agents can access the tools and the resources. We have a translator that translates agent request made using popular protocols like the Model Context Protocol into API request and Lambda invocations. Basically, this means developers do not have to host servers. They could just manage the protocol integration, version support, and version patching, and they could use the Agentcore Gateway. Now you could hang a bunch of lambdas off there. You could have one lambda which implements a couple of tools. You could have endpoints that point to tools. So this is using the Open API schema, and this is using Lambda functions. And what we can do is, with an MCP client, list, invoke, or search tools. So the secret, the difference here in this demo is we're searching. We can search the tools. Okay, now this is the tutorial of features. We created an Amazon Bedrock Agentcore Gateway with Lambda-backed targets. We use the Agentcore Gateway semantic search That means when we create a gateway, we define that we're going to use a semantic search, so some additional stuff comes with it. We use strands agents to show how Agentcore Gateway search improves latency. Okay, and these are the prerequisites: strands, Python, credentials, Bedrock, etc. Now, the other purpose of this demo is that Agentcore Gateway helps solve the challenge of MCP servers having a large number of tools. So, basically, without the search capability, when you go to list all the tools, you can get 360 tools back. If you use a search, you could basically return the 4 most relevant tools. So it's going to be much faster with the search than without the search. So that's the goal of what this demo is trying to do. Okay, so the notebook structure, let's see. In the notebook that we're reading right now, we're going to provide the Agentcore Gateway search. And by the end of this tutorial, we will understand how to use the Agentcore Gateway's built-in search tool to quickly find relevant tools, and how to integrate the tool search results into Strands agents for improved latency and reduced cost. So it should be faster and it should reduce the cost. And the reducing of the cost has to do with the token reduction, which could become significant with a large number of tools. Okay, so the overview of the notebook structure: understanding the fundamentals of the gateway search, preparing a notebook environment, setting up a gateway that has hundreds of tools, searching for tools from a gateway, using Strands agents with an MCP server that has many tools, and adding tool search results to the Strands agent, and showing 3 times the latency improvement by using the tools. Okay, so let's move on. And I just ran all of these cells to speed things up for us. But here's some of the things you have to know when you create this gateway. You have an option to indicate that you want the search enabled. And the search will enable 3 things. 1, the vector store is created. So it stores the tools in a vector store so you could search them fast and you could retrieve them. The vector store is populated as you add more tools. And the MCP-based search tool does add a search capability that's namespaced with Amazon to not clash with any of your names, but it's used to search with an argument called query. Okay, so when the search tool is invoked, the gateway service performs a semantic search using the query, matching it against available tools, names, descriptions, input, and output, and returns the most relevant tools in descending order. So we know what we're trying to do. Let's just try to figure out how it's done. So I'm going to go through the cells right now so we can take a look. We installed. I got a dependency error. I don't care. It worked. And the incompatibilities, the conflicts don't seem to concern me at the moment. And then we imported the Python libraries and loaded the variables. We loaded the Strands agent. We loaded a Bedrock model, a Strands Bedrock model, and we imported a null callback handler. And then we import the tools, the MCP client, the MCP agent tool. And we've seen this MCP client before. The streamable HTTP client, that's the HTTP client that we set the bearer token in. And we have certain types that we use, a tool and an MCP tool. Let's see the difference between using those. And we have a gateway name, okay? So we ran that, and I got some dependency error, which I don't really care about at the moment. Is this a warning or is this an error? I don't know what this thing is, but I ignored it. Okay, now we set up a logger for Python and we set the basic logging capabilities. We're not going to see that unless we log into Amazon, which I'm not going to do. And then I checked out the Bodo 3 version. I'm just printing it out. Now, I create a session, a Bodo 3 session, and I define an Agentcore client, which is the Bedrock Agentcore control client. Now I'm setting up the gateway that has hundreds of tools. So basically what it's saying here is that, you know, typically we'd use CloudFormation and Terraform and CDK to build infrastructure. But in this case, we're just using the control plane APIs directly. So this client control plane helps us control creating our gateway and stuff like that. So it says that we need to create a IDP, right? A credentials provider. We need to create a gateway, and then we create targets to expose the MCP tools. Now, these could be implemented with Lambda and RESTful services. And this tool we use, Amazon Cognito. And so what we do is we create these Lambda IAM role, calculate a Lambda ARN, a restaurant Lambda ARN, a Cognito client, etc. And you could see the Lambda codes over here. Under the calculate, you got a Lambda code. Under the restaurant, you got a Lambda code. Okay, so if you look at one of these, sometimes it's just a dummy thing. Sometimes it adds or subtracts numbers. In the case of the restaurant, Lambda is really getting the event, getting all attributes of the object, and saying booking ID for this number of guests, this restaurant name, this booking date, this booking hour, and the guest name, and this is simulating a booking, but it's not doing anything real. Okay, it's not calling an API. So these lambdas are used, but they're used from the Agentcore, so we're okay with that. Okay, now here I'm opening the restaurant API JSON file, the API spec, and basically I'm printing it out. You know, it's basically the schema for the API call. And then we look at the calculate API, and we get the schema for adding numbers, subtracting numbers, multiplying numbers, etc. Now what we do is we import display and code. This is really nice, and we open up the Lambda code and we display the code. Okay, and this is the code. It's nice to know that we could print code. And this is the Lambda function code for the restaurant. We're just printing the code. Good to see that we could do that. In the other demos, we're writing the code to the file that shows up here in the directory. So You could look at it later on as well, but this notebook is good enough to scroll back and forth and look at the code. Now what we do, here we create the gateway lambda. And we're doing that with the utils, and we're pointing to the zip file and giving it a name. Lambda function will be created. We're printing out the ARN, and if it failed, we're printing out the failure. So here we're reading the code from the zip file. We created the IAM role. We attached the policy. We have the role, and notice this is my Amazon account. This is the interesting thing. It pulled my credentials, which does not have my Amazon account listed explicitly, and it basically took my credentials, my username, password, and it created the ARM for the IAM role. Okay, now here the calculate lambda, same thing. It gave us the role for the lambda. No, it gave us the function ARN for the lambda. So this is calculate. Okay, now we create the gateway lambda. So here we're reading the zip file, creating the IAM role for the lambda, policy for the IAM lambda. This is the restaurant lambda, so it's a different lambda. And we are creating the lambda function, and we got the ARN for the lambda. And the restaurant lambda response, we're getting the ARN and just displaying it. Now here we set up the Cognito user pool. So utils does have a function with the set up a Cognito user pool. Like I said, I might have added it here, but it's really trying to read this one first. If it can't find it, it'll use this one. And if it can't find that one, it'll use the utils in the virtual environment, which it is a different utils in the virtual environment. So it's got a certain pecking order here that it's looking for this utils. And so let's assume it's this one it finds. And I'm just saying that because in the previous demos I had a hard time finding this. So what I did was just copied it here. We could try removing it, but anyway, the point is that the utils set up Cognito user pool actually creates the user pool, creating a Cognito user pool. It was called MCP server pool. User created with an ID, creating Cognito app client. This is the client name. It has an ID. This is the ID. It created a test user. It set the permanent password for the user. It has the pool ID, the discovery URL, and the client ID. Now, this is a little bit different because it didn't use my user ID from the credentials, my credentials file. It actually created a user in the user pool. So keep that in mind. Now we get the bearer token. Bearer token is retrieved successfully. And now we define the gateway IAM role. And we give it the calculate lambda role and the calculator lambda ARN and the restaurant function ARN. So we have a list of ARNs, and we're creating a role for that. This is the gateway search agent core role that I used. It's attaching this policy. Gateway IAM role created is called this. So this is the role behind the Agentcore gateway. that's hitting on the lambdas. That's used to execute the lambda targets. Now here we create a couple of helper functions with the control plane APIs. Here we're reading a JSON spec file. Here we're listing the gateways. And so there's a couple of things that we have to understand, which are common here, right? There was a control pane API. There's a toolkit. There's what's the other one? Let's see if there's let's not confuse you, because there's several things you could use in Agentcore, and you use what you need. Okay, so let me just look here for a second. Okay, let's just continue here for a second. Okay, so now we create the gateway. We got the auth config, cognito, client ID, discovery URL, search config. We got this MCP protocol. It's a semantic search and a supported version, and we create the gateway. So notice we have to have the search config when we create the gateway, because that gives us the semantic search. So the gateway name, the gateway role, ARN, the authorization type is the Cognito JWT token. The protocol is MCP, and we have an auth config with Cognito and a search config. Okay, so now this is the function creates a new Lambda target on an existing gateway. So this function create target takes the existing gateway and adds a target. So here it adds the target configuration, and it's a function that adds the target configuration and returns a target ID. And you could keep calling this and adding lambdas and stuff, or whatever you want to. This convenient function is adding lambdas. Okay, now here's a nice colorful picture. Creating your first Agentcore gateway. And this is really a general view, a high-level view of what we're doing, okay? So this is a good picture for one reason. It shows you that you could call different tools with different outbound access control, okay? So in this case here, the user is talking to an app. The app is talking to maybe Shan's agent. We're using OAuth token for inbound access. We're invoking the MCP tool. We're hitting on the MCP URL. We are hitting on Agentcore gateway. We're using an identity provider, and we validate our OAuth token, and we allow the request to access certain tools. Of course, we got Amazon CloudTrail and Agentcore Observability and Agentcore Identity. Nice buzzwords, but the bottom line is auth in, key out. So here we do outbound, and with Agentcore Gateway, we're supporting multiple outbound access control strategies, right? One is using an API key to a REST endpoint. One is using IAM to a Lambda function. One is using OAuth token for a third-party service such as Google, Salesforce, and anything that you want. So I like this picture. And it's sort of demonstrating that you can have different outbounds, but But let's see what we're doing here. Okay, so here we created a gateway name called Gateway Search Tutorial. The gateway created with an ID. We got an ID for the gateway. And then we assume we already installed a pair of Lambda functions, one for doing simple math calculations and one for creating a restaurant reservation. Now, the gateway is created. Let's add a target for making the restaurant reservations via the Lambda. And what it does is you read the spec, you get the ARN, and you create gateway target. Gateway ID, Lambda ARN, food tools, restaurant tools, restaurant API spec. So notice this is kind of loaded statement. It's going to get the restaurant API spec, and it's attaching that to the gateway as a target. Okay, so we got the restaurant Lambda ARN, and we got the restaurant target created with an ID on this gateway tutorial name. Wonderful. Okay, here we add a second target, this time with the Lambda that implements the 4 basic tools: add, subtract, multiply, and divide, and a set of 75 generated tool definitions for investment management training. We should look at this. It's right here. But basically, we read that spec. We got the Lambda ARN. We're printing it, and we create a gateway target. Gateway ID, Lambda ARN, calculating tools, calculated tools, calc API spec. So let's just look at this really quick before we move on. What is in here? How many tools are in here? We got like 75 or more tools in here. And now it doesn't mean, let's look at the Python code. It doesn't mean these are all implemented. So in the Python code, we are just supporting 4 tools. But the API spec is exposing more than 75 of them, so right? So let's see what this demo did for us. Okay, so to demonstrate the power of the gateway search, let's add a few more copies of the calculator target, so we end up with 300 tools. So add more tools. Added targets. It added different target names. Calculated 1, calculated 2, 3, 4, and then we added more tools. And this is what printed out. Calculated 2 target was created with this ID, etc. So now we're looking for the tools, and what we have, we do a search on listing the gateway targets, and what we have is calculated tools, calculated 2, food tools, calculated 3, calculated 4. So searching the tools, here we have this gateway get gateway endpoint function, and now this is concept of inspector, and I like to call it introspection, right? But it's MCP inspecting against your gateway. And so what it's doing, what it's capable of doing, you're capable of querying the gateway to find out what kind of tools that you have available to you. And this is the reason why we use MCP. There is a context. Our agent and large language model need to be smart enough to find out what the query is. Like if the user's asking to add 2 numbers, it has to figure out what tools we have and figure out which tool we should use. So this this inspector is used to determine that, because we want to do things as efficiently as possible. If I have 1,000 tools and I have one that adds 2 numbers, I just want to use that one. I just want to find that one to use it. I don't want to list all the tools and try to figure out which one inside gives me the answer. Okay, so now we get the gateway endpoint. Notice it ends in an MCP. We secure MCP with the bearer token. So we printed the JWT token. We get the bearer token from Cognito. We print it. We instantiate the model context protocol inspector. We installed it. And then here we're invoking the gateway tool. Okay, so what we're doing now is using JSON RCP. We're making a tools call, and we have the tool parameter. So let's see, where was the tool parameters? I guess we didn't call it yet. Yeah, so this is just a function. This is just a function defined. And then it's showing us another then it's showing us another way to list the tools. MCP has this tools list method. You give it a gateway ID and token, and it retrieves the full set of tools. Now, keep in mind, you can get the full set of tools, but do you want and need the full set of tools? You're paginating through these tools, but you might not need them all. Get all agent tools from MCP endpoint. So this is the one that does it. It uses this method tools list with empty parameter list, and it gets more tool. It gets all the tools. So this returns the full tools list just using MCP. Now this is the different way for the client. Using a JWT token, using a streamable HTTP client, get all the agent tools from the MCP endpoint, using the client, the token, and the endpoint. So this actually spit out some values. We're adding this tool, adding this tool, adding this tool, and we got um, yeah, so this is doing pagination, listing tools for this gateway. Let's see. This is getting the next page of the tools. And it says the total tools found is 318. Using JSON RPC with MCP tools. Now they're going through a way to use Strands Agent List Tool Sync with pagination and get all MCP tools from MCP client. Does exactly the same thing. I don't know if they time this, but let's give it a try. It says we've now seen 3 ways to list the tools: directly using JSON RPC, list tool sync, and using the MCP inspector tool. Now what we're going to do is we're going to have a tool search, and we're going to use this name which comes with the Agentcore and a query, and we're going to invoke the gateway tool with the gateway endpoint, the JWT token, and the tool params. And in this time, we're starting to time this thing, but with this time, the tool search comes back in 98 seconds, and it returns the top tool. So the query is find me 3 credit research tools. And it looks like it found 1. Now they're saying this is fast. This is not fast. I mean, it's fast for humans interacting with agents, chatbots and stuff, but this is not fast. We're APIs can go like 100 milliseconds or whatever. Okay, using Strands agents with MPC server has many tools. So here we're using Anthropic. Okay, let me see what we didn't use the LL model to list any of these tools. That is very interesting. So Strands agent was capable of giving a query and finding the tool. Now, correct me if I'm wrong, we did not use an LLM so far. Let me see. Where's the... We didn't... I believe we didn't instantiate an agent yet, right? We're just using the gateway, the bearer token, the MCP URL. We're using MCP, let's see, nope. So far we haven't introduced an agent. So it's very interesting, I'm starting to realize this, that everything we did so far didn't even use an agent. It used calls to the Agentcore, 3 different ways it got to tools, and the agent, now we're introducing the agent. The bedrock model is Claude, and we get the bearer token, and we create an MCP client. With client, we instantiate a simple agent, and now here it got the tools and passed that into the agent instantiation. And now what it's doing is adding 100 plus 58. In this case, it did find 318 tools, and it added the 2 numbers. And this sentence here is saying that we could call the specific tool by name if we want to. The Strands agent framework allows you to do that. So let's just see what this is doing. Okay, we have a bearer token. We put it in the streamable HTTP client, and with client we instantiate agent. We get all tools. We have a simple agent. We pass in the tools. Direct results, simple agent dot tool, calculate, add 2 numbers. So it takes this simple agent and it does a dot tool on it, dot tool name, and it gives us an output. So here, as you notice, the sum is 30. Okay, and here we're doing this differently. This is the function to do a search tool using MCP tools, and notice we instantiate the tool, MCP tool, with this name, and we have a query. And this is search using strands, client, query, agent, bedrock model, get search tool client, null callback handler, direct result, search on the query, load the JSON response, search for tools, And this function here is find strands tools. So MCP tool, notice here, this MCP tool here is something we imported from strands tools, right? So this is a way to use the strands framework to get the tools. Get bearer token, get streamable HTTP client with the bearer token. With client, you instantiate the agent, get search tool. Simple agent tool dot Agentcore search. Query is find equity trading tools. Now this gets the token, puts it in the MCP client, streamable HTTP client, and with the client it searches using strands. Find trading tools. Find credit research tools. Okay, so it's finding these tools by name. Screen equity securities. Okay, now we're going to look at how the tools returned from the search can be added to the strands agent. Tools for doing addition, subtraction, multiplication. Find strands tools. So yeah, this is going into the strands framework, the agent framework, and actually getting these tools and using them to do a calculation. So it's telling us, I'll calculate this step by step. First, let me calculate 10 times 2. 10 times 2. Then it does subtraction. Now we'll divide 20 by 2. And it gives us the answer here. I don't know what these warnings are. Client tool calculate is not listed by the server. I think what's happening here is it's getting the tool from the strands tools, and it's not getting it from the lambdas. And so it's giving that warning. Okay, now here, searching for the adding tool from the endpoint with full set of tools. Tool search. Gateway endpoint. Tools for multiplying two numbers. Top tools found. Top tool found. Calculate tools, multiply numbers. And it shows the latency. Okay, now they're comparing. We're going to show 3 times latency improvement with the tool search. And so basically, we're checking out our tokens and our elapsed time here, and we're doing iterations, and we're just authenticating. And now here we're looking at comparing the tools. So this is using the agent. Using all the tools. Total time is 15 seconds. Tokens are 303,000. This is the example using the search, and we're using much less tokens, and it is faster. So here's the comparison. The latency without search is 15 seconds. With search is 14 seconds. Tokens without search is 303,000. Using search is 1,000. And they talk about a conclusion here that you could have a lot of MCP tools, and the semantic search will find the relevant tools, and you could save time and money. So what did we learn? Creating a gateway with a semantic tool search enabled. How to add multiple gateway targets to surface 300 plus MCP tools in a single endpoint. How to list your tools on the gateway using 3 different approaches. How to use built-in semantic search tool to find relevant tools. How to integrate search with your strands agent, and how to compare performance of an agent using server with hundreds of tools versus one that used semantic search to narrow the tools. Okay, now I have an option to clean up resources here. Let me try to clean up the resources and see if things get deleted. I really need to log on to Amazon to see what I have resources hanging around, because I don't want to get charged for them, but I just want to finish this demo, and I'll go over there and look in a little while. Now this is deleting all the targets. Should delete Calc 4. Okay, that completed. Let's delete the gateway. Lambda ARNs. We're deleting the gateway lambda ARNs. Delete the role. So this is good. Yeah, the demos didn't look like they deleted the cognito user pool and stuff like that, but this did everything. So, you know, like I said, we're given this project with these lambdas, with the zip files, with the notebooks, with the requirements file, with the utils, JSON specs, API specs. I mean, and it's still, I mean, it's simple. It's listed as a simple demo, which is great, and it gave us a nice diagrams that we could look at, which were extremely helpful. So I think Amazon did a very good job with this. I am kind of at the point now where I feel like Strands is the hype about Strands is is interesting. I find it to be simple and useful, and I will be using it from now on if possible. And that's really all we wanted to show. The search tools, that was interesting, the semantic search. Now, keep in mind that I think what we got out of this, and you should have gotten out of this, that the MCP protocol and the MCP context allows you to inspect your tools. So even though you have APIs and lambdas and stuff like that, it's really adding context to that so the agent and a large language model can do certain things that it needs to do. And listing tools or finding an appropriate tool to do something for a user is really valuable, and you want to do that efficiently. I think we'll all agree that this isn't extremely fast computing. This is interactive chatting and agent-based simulation modeling and stuff like that. So anyway, that's all I wanted to show. Thank you for joining. And if you try to go through any of these tools, feel any of these projects, feel free to comment on what we're doing. And that's all I have. See you.